Problem 2. Using the law of cosines in a side-side-side situation. In triangle TUV, TU equals 4.4, UV equals 7.1, and TV equals 6.7. Find the measure of angle V to the nearest tenth of a degree. So note, this one's different. We know all three side lengths, and we're trying to solve for an unknown angle measure. So we should definitely draw and label a diagram. We can see that here in step 1. T, U, and V clearly labeled as the vertices, and then the lengths of each side labeled as well. Step 2, we'll use the law of cosines to set up an equation. In this case, TU squared equals UV squared plus TV squared minus 2 times UV times TV times the cosine of V. So this already is transitioning to more of an intuitive approach, where rather than labeling with A, B, and C, each of the side lengths and then the angles as well, A, B, and C, just understanding how these sides relate to each other in the formula. Substituting the values we know, we find 4.4 squared equals 7.1 squared plus 6.7 squared minus 2 times 7.1 times 6.7 times the cosine of our unknown angle V. In step 3, we're going to solve for the measure of angle V. To begin with, we simplify. So 19.36 equals 50.41 plus 44.89 minus 95.14 times the cosine of V. Then we solve for the cosine of V, isolating it, and we find negative 75.94 divided by negative 95.14 equals the cosine of V. Next, we'll solve for the measure of angle V using the inverse cosine, applying that to each side. So V equals the inverse cosine of the fraction negative 75.94 divided by negative 95.14. And we use a calculator to find that the measure of angle V is approximately equal to 37.04. So we can state the measure of angle V is about 37.0. Your turn. In triangle TUV, find the measure of angle T to the nearest degree.